All right, guys, review number 5, unit number 5, 3 days on valence electrons, Lewis structures, and molecular geometry. You got to admit your test is going to look a little different here where you can't be drawing Lewis structures, you can't be drawing molecular geometries. You can't draw Lewis dot structures, so I'm going to talk a little bit while I do this about how I can ask these questions. You'll get mini quizzes in the sample style and be ready to go. So first thing in your packet of review notes is a chart that shows you valence electrons and Lewis dot structures. Lewis dot structures are nice, but the best way for me to ask these on an exam would be how many dots does something have, which is the same idea as how many valence electrons does something have. If you look at the periodic table I had attached last unit to Unit 4 nomenclature, Group 1 has 1, 2 has 2, 13 has 3, 14 4, 15 5, 16 6, 17 7, and 18 8. So just your number, or your number and ignore the 1, is 2 separate answers. Your number of valence electrons, and because it's your number of valence electrons, it's the number of dots you have on your Lewis dot structure, and it's the number of electrons those atoms kick into your Lewis structures, which is the big idea. So, we're going to start at the beginning. I couldn't put your Lewis structures in your packet. So, 2 options like always. Go through and try to draw them yourself and check them with my answers, or follow along, pause where you want, work on them, or work through them with me. Whatever you like, you can work through them all at once. I guess it's 3 options, all at once, one at a time, or with me the whole way through. So I'm going to start with NH3. I have your instructions right there for you. Let's do an example. 1 nitrogen, 3 hydrogens. So that's going to get me my count of valence electrons from here. Nitrogen is in group 15. Get out your periodic table and find it. Nitrogen's in group 15, so it gives me 5 valence electrons. Each hydrogen gives me 1. There are 3 of them. So don't forget, because I have 3 hydrogens, each one contributes 1. 5 plus 3 equals 8 electrons to use. Counting valence electrons is important. There's a good question. How many total valence electrons? Run your count. So now I put the atom I only have 1 of in the middle, and we're not doing molecular geometries yet. We're just doing Lewis structures. If you want to draw this in the correct molecular geometry, if you remember those, go for it. So I've got nitrogen in the middle. Why? I only have 1 of it. What always goes in the middle if I've got it? Carbon. We'll give him 3 hydrogens. So nitrogen had 3 hydrogens, and if you remember, each one of these bonds used up 2 electrons. So, in connecting 3 hydrogens, I used 2, 4, 6 electrons to have 2 left. Hydrogen only ever wants 1 bond, no dots. Hydrogen, 1 bond, no dots. So, with these 2 extra electrons, where do they go? Well, not on hydrogen. They have to go on nitrogen. And we have that thing called the octet rule, where everything got to have 8, with the exception of the exceptions, which we'll go over next time. So everything got to have 8. Nitrogen sure doesn't. 2, 4, 6. Where do those 2 electrons go? Those are dots on my nitrogen. So other than these obnoxious pink circles, there is your Lewis structure for ammonia, NH3, not drawn in the correct shape, but a Lewis structure. This is where if you want to pause and work through these 2, you can go for it or follow along with me. Carbon tetrachloride, CCl4. Carbon's going to give me 4 electrons because it's in group 14. Each chlorine is 7, so 28 electrons total there is going to give me 32 electrons for carbon tetrachloride. Who goes in the middle? Carbon always goes in the middle. That's not even a good question. With its 4 chlorines around. I used 8 electrons, 2, 4, 6, 8, leaving me 24, and that carbon is happy. Carbon should always have 4 bonds. You remember that. Now these chlorines also have a bonding pattern that they love. Group 17 loves 1 bond and 6 dots. That should be pretty easy, because that'll give them their 8 electrons. 2, 4, 6, 8. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Good. So questions I could ask, how many dots did each chlorine get? 6. How many bonds did carbon make? 4. How many bonds did chlorine make? 1. Are there any dots on the central atom? No. So let's make sure I use these electrons. I had 24 to use as dots. I put down 6 4 times. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Did I use 32 total? I bet I did, because I used 8 on a chlorine 4 times. That one's good. H2O, 1 from each hydrogen plus 6 from the oxygen gives me 8 electrons. Unique element in the middle. Lots of people draw this one as H in the middle and 2 O's. I'm not sure why, because it's H2O, so keep your eye on that. Oxygen goes in the middle. Hydrogens on each side. And I used 2, 4 electrons to do that. I need to put 4 more electrons on there. Hydrogen says, none for me, thanks, I'm full. And oxygen goes, ooh, me, because I have 4 and oxygen needs 8. 2, 4, 6, 8. Questions I could ask? Bonds on the hydrogen, 1 each. Bonds on the oxygen, 2. Pairs of dots on the hydrogen, 2. Or dots on the hydrogen. Read that carefully. Dots, 4. Pairs, 2. There's water, and that's our intro to Lewis structures. Next lecture goes over exceptions. One after that's molecular geometry. See you then.